In this video, we're going to talk about another rule that helps to take the derivative, and that is the constant multiple rule. Here's the statement of the constant multiple rule. Here we have a function g of x, and this function g of x is built by taking a constant c and multiplying it times some other function. So I have a function f, and I multiply it by a constant, and that's how g is constructed. So then over here, this tells us how to take the derivative of a function like that. The derivative of g will be that same constant. So I really don't have to do anything with the constant. I just basically rewrite it and then multiply by the derivative of f here. Okay, so the constant multiple rule works pretty nicely, and it's a good one to keep in mind. Later on, we will have a rule called the product rule, and the product rule is a more complicated version of this constant multiple rule, but it's more general. It applies to more general situations when this is not a constant. So sometimes there is a tendency for students to use the more complicated rule, and they kind of forget about the constant multiple rule. But you really don't want to do that. You don't want to use the more complicated rule in simple situations like the one that we're talking about here. So this is an important one not to forget later on. All right, so here's an example, our first example using the constant multiple rule. So what we have here is a function f of x, and it is a constant, right? A 7 times a power function, x cubed, right? And we want to find the derivative. So how that works is what we will do using the constant multiple rule, right? We are just going to rewrite the 7 right here. We just rewrite it. We don't really do anything with the constant part of it. And then what we're going to do is multiply times the derivative of x cubed. Well, x cubed is a power function, right? And so we would use the power rule to take the derivative of x cubed. So we're going to bring that 3 down, and then we're going to subtract 1 from the 3 to get 2. Okay? So that's what the constant multiple rule says. Just rewrite the constant part and multiply times the derivative of the function part. Of course, here we can simplify this, right, by just multiplying the 7 and the 3 together. And so we get the derivative of 7x cubed is 21x squared. All right, in example 2, this situation is again slightly more complicated. Here we have a function 9 over x squared, and we want to find the derivative. Okay, so that 9 up there may, at first you may not recognize what to do with it, but what I generally like to do is just sort of pull it out in front so that it looks more like the constant multiple rule. And sometimes when it's a fraction like that, it's a little bit confusing to people, so I just think of it as pulling apart a big fraction like this. And just remember how multiplying by fractions work. If I want to multiply two fractions, I just multiply across the tops and the bottoms here, right? So 9 times 1 would be 9, and on the bottom 1 times x squared would be x squared. So this function that I have here is exactly the same as this. I can multiply it back out to check to see that I did everything correctly here. Okay, and now that I have that fraction out in front, I'm going to do two things. Here, 9 divided by 1, I don't really need to write that exactly as a fraction. That's just equal to 9, right? And then 1 divided by x squared, that's going to be x to the negative 2 power. Okay, so what I have is a constant, right? A number times a power function. Okay, so x to some number power. So again, no calculus has taken place here. We are just rewriting our function so that it is in the constant multiple rule format, and it's a constant times a power function. And so now we are ready to take the derivative. All right, so the constant multiple rule says just rewrite the constant. So I have a constant of 9, I just rewrite it, and then multiply by the derivative of the function part. Well, the function part is a power function, right? So I would use the power rule. Bring the negative 2 down, and then subtract 1 from the exponent. So negative 2x to the negative 2 minus 1, that's going to come out to be a negative 3, right? And then I'm just going to go ahead and multiply 9 times negative 2 to get negative 18. So the derivative of 9 over x squared is negative 18x to the minus 3. All right, next up, another example of the constant multiple rule. Here I have a pretty complicated looking function, so just like before, I'm going to spend quite a bit of time getting it into the format that I want to, and that is going to be a constant times a power function in this particular problem. Okay, so again, right off the bat, I'm going to pull that 15 off the front and the 7 off the front here. And again, just like before, if I multiply this out, I'll get exactly what I had here. If I multiply the denominators out, I'll get exactly what I had here. So this is exactly equal to what I started with. Also, I'm going to get rid of the radical notation. I'm going to convert that over to fractional exponent notation here. So the cube root of x squared is the same as x to the 2/3 power. So that's all I did in that step. Here I can simplify what I had in the bottom part, right? Here I'm multiplying like bases, right? This x has an understood exponent of 1, and I'm multiplying it times x to the 2/3 power, right? So when I multiply like bases, I add the exponents together. So if I have a 1 plus 2/3, getting a common denominator and adding those together, that's going to give me x to the 5/3 when I do that. Okay, and I'm going to keep working down here. I'm going to use the other algebra fact that we've been using to rewrite 1 over x to the 5/3 as x to the negative 5/3. Okay, so again, all this was algebra in here, all just algebra steps. I didn't take the derivative at all. And what my goal was to reduce this down to a format that's easy to take the derivative of. So here I have a constant, right, and just a number, 15/7 times a function, x to the negative 5/3 power. And so, and that function happens to be a power function, right? So this is something I'm going to use the constant multiple rule and the power rule on. So now I'm ready to take the derivative, right? The constant multiple rule says, hey, just rewrite the constant. You don't really have to do anything other than just write it again and then multiply by the derivative of the function part. So the function part is a power function, right? And so I'm going to use the power rule on it. So I'm going to bring the old power down, then I'm going to subtract 1 from the old power there. Okay, and so then the derivative is done there. I just need to clean things up a little bit and simplify as much as possible. So what I'm going to do is multiply 15/7 times negative 5/3, right? You're going to have to reduce that down a little bit. That's going to come out to be negative 25/7. And then I am going to have to actually subtract these numbers here, right? Get a common denominator. 1 is 3/3, so I have negative 5/3 minus 3/3. That comes out to be negative 8/3. So that is the derivative of this function here.